right. I'm going to do a quick review of what we've done last time and kind of take you through the things that we've talked about. First, we talked about, essentially, it's all about polymorphism, the universal polymorphism, the things that we have gone through. The very first thing we've gone through was inclusion polymorphism that we showed you how. Let me just bring up the project and show you one by one. So we brought up the definition of inclusion polymorphism, which essentially was creating virtuality through interfaces and abstract-based classes. Essentially, we talked about abstract-based classes. We said they are the ones that have pure virtual functions, and they enforce a design for the children or the derived classes that we have. And talking about kind of reviewing what we have done in OOP345. And then from there, we jumped into talking about how when you have references or pointers of the parent in derived class, especially in pure virtual functions, how can you upcast those things to the class that is actually implementing them? For example, we mentioned if a class is comparing itself, if a circle is comparing itself to a shape, how we actually upcast that one. And if the upcast fails, let's just bring it back quickly to what he had. So we simply say we upcast, and when if the upcast fails, the pointer is going to be null. Then we can detect that the upcast is not successful, and therefore this is not the cast that is valid. And we can actually detect it that way. Dynamic cast always works on pointers, and it upcasts the parent class to the child class if possible, which means if you have a child class that is held in the pointer of a parent, you can always access the properties of children if the actual object that is being derived is the one you're casting it into, which means if I have a circle and I cast it to a square, nothing's going to happen. It's going to be null, and I can detect it that way. So that's essentially was the inclusion polymorphism that we went through. Then after that, we did a review on OOP345 templates with functions, and we mentioned functions have signatures, and because they have signatures, they are detectable by the compiler, and compiler can guess what it wants to create out of a template. The example was the swap thingy that we created, and when I said swap is swapping through pointers of pointers to two objects of the same type. Now, if the addresses that I'm passing are double, compiler can guess that the type is supposed to be double. Therefore, it generates a double code for it. And when it's character, it generates the character for it. Then we talked about creating template specializations. And we said whenever we need to have a specific type of version of the template created for a type that doesn't comply with all the requirements of the template that we have, we can specialize it to something new. We gave the example of the largest thingy, and we said largest requires the greater than operator to be applied, but our container doesn't have greater than operator applied. Therefore, I have to specialize it to something to be used. We said we have two ways. Bad way is to just overload. And for all those people who are going back there, actually, if you are sitting over here, maybe that's a better thing to do. Otherwise, you can't see a thing in here. Anyway, so as I was saying, you can specialize it. Either we can overload or we can specialize. If we overload always supersedes the class definition, the function templates. And we said overloads are essentially very similar to what we have with the specialization. You literally overload and say what I want the function to be. And because the overload matches the function call inside your code, the overload's going to get called, and the function is not going to get created by the compiler. Problem is that it defies the whole purpose of having a template, which means the reason we create a template not to bloat our executable with different functions when they are not needed. Only functions will get generated if we call them. If we don't call them, our executable will not contain any of the things that we have. Therefore, overloading kind of defies the whole purpose of having a template in the first place. So whenever we want to have a specialization made, we literally write the overload first, test it, make sure everything works, then convert that to a specialization by adding a template signature at the top with an empty placeholder and specifying exactly what needs to be triggering this thing. So when you literally put the container over here, you're telling, hey, if the function that is down there is requiring a container, forget about the regular one and call the specialization instead. That's how we actually specialize any type of function template. Having that, we came to understanding how conflicts can be resolved. We said when you have a situation where the compiler cannot decide which version of the template to create for you, you can force compiler to do so. How? We mentioned for the largest thingy over here, because the types have to be the same. If one is integer, the other one is double, the compiler doesn't know which one to generate it with. Therefore, you can tell to the compiler, don't look at the arguments that are passed, create the double version of it. So essentially, I force the compiler to create the double version of my function template. And then because now it's the double version being called with an integer and a double, it's going to upcast the integer to a double and call the double function, yada, yada, yada. So that's what it is. You can literally ask the compiler to create a version of a template and then pass whatever you want. Then it works like a regular function. That was the gist of function templates. Then covering that, we went to actual templates themselves, which I'm going to pause. Okay, so when we are dealing with classes and templates, the story is a bit different. When we are dealing with classes and templates, the story is a bit different. And I now see that the oh yeah. So when you are, we actually had set a startup project. So when we are dealing with classes, we said when compiler compiles a class, this is the integer array that we created in OOP345, a dynamic integer array that could replace the integer C's integer arrays. C language is integer arrays, and we said it's a more efficient way of using an array than regular array that we have. It's more intelligent than that. It knows what its size is. It can make sure that you don't exceed the size of the array, and it can handle different scenarios, automatically expand itself. It can change its size. It can loop back over its own data, and so on and so forth. We said when the compiler compiles this thing, whenever you want to use this thing, if anybody wants to use this, What the compiler does essentially, as we went through compilation sequence, compiler compiles your usage of the integer array and the header file at the same time, which essentially looks at the header file and the calls that you made and compiles your function calls and class usages. And then after it's done, it compiles the source code of integer arrays separately, puts them together. Therefore, your function call and class generations in your user file will use the binary code of the integer class itself, and therefore your application works. Again, I see blank pages in your face. Do you remember? In your faces, do you remember the compiler thingy that I created? And I said how compiler works, and each module gets compiled separately. That's what I'm talking about. So the header file and the usage of integer array will get compiled, the binary code created. Then the integer array will get created, the binary code created, and everything works together using a linker. We said because of that fact, when we are actually using templates, we cannot have a module for a template. Why can't we have a module for a template? Because templates the binary code for templates are created at compile time. And because it's created at compile time, the compiler requires to have all the details of the source code when it's generating the binary for you. If I have a module for a template, which is a header file and a CPP file, because during the compilation only header file is available, compiler doesn't know how to create the binary. Because of that, all templates, unlike regular modules, must exist inside the header file, and there is no CPP file for a template. Then we went through creation of the template. I said, whenever you are creating a template, create a regular thing, a regular version of it for a specific type, for an easy type. So you want to create a class for a container that can contain any object and do something with it. First, create it for a container that holds an integer inside. Do everything for that and be done with it. And after you finish the whole thing and everything works, then you can convert it to a template. When you're a rookie, when you are experienced, then you can directly program the template because you know all the ups and downs of it, and you don't need to kind of remind yourself of how to create it. In our case, we had this dynamic array, and we said to actually convert this, first I have to create a header file, dump everything inside the header file, the class, anything that I had in the header file of int array will go into that header file, and the CPPs are copied over there too. After doing all that and adding the safeguards, I start converting the template, the regular module to a template module. We said that when you are doing that, the very first thing that you need to do is to add a template signature to every and each scope of the code. That includes even one-liner function prototypes. So essentially, one template for this scope, another template for this prototype, and a template for this constructor creation, another template for the copy. So every single scope will have its own template signature at the top. Then after doing that, then you put your microscope eyes on, and you look at and try to find the focus of your application that you want to, if that's the word, templatize. I don't even know if that's a word, but you want to create a template, right? In our case, because we were creating an array of dynamic integers, we had to change all the integers that were involved with the element of the array to the type we want. So it can be an array of anything. Therefore, integer pointer mdata got changed to t pointer mdata. Therefore, the index operator that returned a reference of an integer now returns the reference of a t, which is any type, and so on and so forth. But obviously, the things that did not matter, we did not change, like the size of the thing that was size t. So we don't change that. And that's that. After doing all that, then came the explanation of class templates not having a signature like function templates. Function templates can just be called, and throughout the signature, compiler can detect which type of template it has to create. Classes don't have that. Because they don't have that, essentially every single class template creation is a specialized one. You put the name of the class, then you put the type in front of it and ask it what type of a class you want it to create. Because of this fact, you have to add the signature of the template to every single class name that you have in your template, with a couple of exceptions. We mentioned, first of all, you have to add the signature T to every single class name, like we have done over here at line 20, but there are 3 exceptions. Number 1, the name of the class that comes at the very first thing that the template statement that we have. That doesn't get touched. Number 2, the names of all the constructors. No constructor will actually will receive the constructor name only, will receive the type, and also the destructor. Other than that, everything has to change. Therefore, we added the type to, for example, the return type of the copy assignment, or the copy constructor, or copy assignment. All the objects that are passed over there, we have to specify which type of dynamic array is being assigned to this one, which type of dynamic array is being copied in here. Therefore, it must have those values. After doing all that, the class template is created, and you can actually use your integer array template and for any type of your dynamic array template for any type of template that we have, and we use it for a container and a double as an example. Are we good? Then we came, after that, I talked about how in old times they used to say you have an app for anything. It's the same thing with the templates. You have a template for any structure, logic, data structure that you want. Most likely there is a template in standard template library that helps you do that. Our key is to know how templates work and then use them properly to do whatever they need to do. And remember, if, for example, you want to do a search, if you think you can write it better, don't think. The one that is templated is faster than you. Always. It's more efficient. So you got to try and using that instead. And also, it's quicker. I think that was the end of the search. Did I started talking about the relationship between classes, or we did not talk about it at all? We didn't talk about it at all? Okay. All right. And now, relationship between classes. All classes, they have relationship between, all classes involved in an object-oriented design, they have relationship with each other. Okay? Or they have no relationship, or some relationship. Did you guys started doing any of the system analysis and design classes? Do you have any system analysis design? In that one, is it object-oriented or just, so you have use cases and stuff you're writing, right? And you say, this is an actor, this is those stuff. Beautiful. So now, so you know, when we say classes have relationship with each other, what does it mean? Okay? Relationship between classes fall in kind of 3 different categories. Number 1 is that they just talk with each other, and they have no ownership, towards each other. It's like a teacher and a student. The class teacher, the class student. I am a teacher, I'm teaching you guys. So essentially, when I lecture, I have an array of students that I pass to my lecture method. And in that lecture method, I'm invoking your learning method. So you are going to learn from my lecture. Something like that. Okay? And these are communication that is happening between us. If I'm hit by a bus, you're still a student. Doesn't matter if your teacher exists or not. If my class gets canceled, I'm still a prof. It doesn't matter if my students are not there anymore. You don't own me, I don't own you. We have no relation with each other with that matter. This is called an association. When we are dealing with each other, but we don't in any way control each other. Okay? Is that clear? That's student and teacher relationship. I want to give you exactly the things that I'm mentioning over here. The other one is a library and a book. And I have to mention the 3 types of relationship that I'm going to mention to you. You can always have different abstraction regarding the system you are designing. What is abstraction? Seriously? This is one-way communication. Should I bring the talking stick? What is abstraction? I haven't finished that program yet. What is abstraction? Anybody? Abstraction? Seriously? Nobody knows what's abstraction? Okay. So abstraction is a way you look at things, to take what you want and ignore the rest. That's called abstraction. Okay? And abstraction has nothing to do with object orientation. Abstraction is to do with programming. If you cannot abstract your view, you cannot write a program. It's impossible. If I told you to write an accounting program that does accounting, you have to focus on money, how much money you have in an accountant, not the color of the hair of the accountant. That's not important for you. Do you care if I'm bald? Do you care if I can dance? No, I'm your teacher. Your abstraction for me is if I can teach C++ and you can learn. Okay? My abstraction from you is the students who answer to their teacher, not you just sit over there looking at me. So you got to fix that in the next few days, hopefully. All right? So what I'm saying is that all these relationships that I'm talking about, they aren't necessarily carved in stone. If I'm telling library in a book is this type of a relationship that I'm going to explain, you can always design it to be something else if you want to. Having said that, let's continue. The first one was association, where objects are associated with each other. They don't have a relationship with each other. The next one is like library and books. When a library opens, it holds copies of books inside. And it owns the books that it has. But it doesn't mean that no copies of those books don't exist out there anymore. It doesn't buy the license of the book and the book only exists in that library. That's not the case. It copies the books. It has copy of the books. If the library burns down, all the copies of the books it holds will go away with it. But the copies of those books may exist outside. So library holds ownership over the books, but not an absolute ownership. The book in a library can exist in another library. A person can buy it. Do we follow this? That's called aggregation. Aggregation is a bit more strong than association, which means the aggregator who is aggregating its members creates the members out of copies of things that are being added to it and controls its existence. When the aggregator is gone, all the objects inside will get destroyed with it. It owns the copies, but not the class. Does that make sense? It owns the copy, but not the class. That's aggregation. Are we good? Are we okay? The next one is a bit more stronger than aggregation. When you build a house, your house has rooms in it, right? When you have an array, your array has elements in it. Is it possible that I have a single element out there without an array? Can I say, that's an element? Element of what? An element only exists in an array. So essentially, an array creates an element within it. Nobody can create an element just by itself. I cannot say, that's a room. No, the room is inside something. Building, apartment, house, somewhere. You cannot have a room standing by itself in the middle of nowhere. It doesn't make sense. Room needs to be inside something. This is called composition. When something is composed of something else. When you have a house, when you build a house, you add rooms to the house. And it's the house that is creating the rooms that are within it and holds it. And when the house is gone, the rooms are gone with it. Okay? That's composition. So, how does it work? Implementation for it. So as you see, I have a class student. And the class student has a teacher over here, pointer, in it, right? So student comes and goes, has nothing to do with the teacher. It just has a pointer. Like if you're going to say, who's your teacher? That's my teacher. You're just pointing at it, right? Why did I say OOP244? I don't know. OOP345. Anyways, so if I look at the class teacher, teacher has a name, and it has an array of student pointers. And that's it. I don't have anything else into it. When I add a student, I simply get the address of an already existing student out there, and I add its address to the teacher. When the teacher is gone, the destructor of a teacher doesn't do anything to the students. Students still exist out there, but if the teacher exists, it knows which students it's teaching to. Got it? That's association. The classes know each other, but they have no control over each other. Aggregation. So I have a class book, and it has a title, and whatever. Then I have a library. Library has an array of pointers of books. So far, it looks like an association to me, right? There's nothing specific happening in here. But as soon as I go inside library, something strange happens. The add book of mine, it's receiving reference of a book, and then creates a copy of the book and holds it in its pointer. So it's not the book outside. It's a copy of it. And therefore, when library goes away, all the books inside are deleted. So the library owns the books inside. This one is aggregation. All right? Are we okay with this? What else do I have? Okay, yeah. And last but not least is composition. In composition, I have a classroom. Room doesn't even have a public constructor. You cannot even instantiate a room. That class is forbidden to be created. You cannot even create it. It has a friend house. And that's the only way, the only valid way to have the friend being used. Whenever you create a function, a standalone function, and it's a friend of a class, it means you're lazy and your design is bad. Because always if you are creating a helper, helper is supposed to call accessor queries and modifier methods of a class and help the class do whatever it's supposed to do. Like when we did outputs with that one. If you're, like when you did the insertion operator overload for cout, you should have a display and it calls the display. Making that a friend of a class is a design flaw. It means you are giving the key of your class to an outsider. They can change the state of your class without your class knowing, which is not good at all. But in this case, it's a valid thing to do. The house over here becomes a friend of a house, of a room. Now, the friendship in object orientation, I always give this example. It's a very cruel and sad example, but it's real. Okay? Many of us have pets, right? I have a dog. I love my dog. Like, it's really serious. It's a member of our family. Okay? I can say I'm a friend of my dogs, right? No, I can take my dog to the vet tomorrow and I can put it down. Can't I? When I say that, it breaks my heart. But that's reality. That's what friendship is in object orientation. It's ownership. It's not friendship. When you make something friend of something else, it owns it. That's how it's supposed to get created. Because room is fully private, no one can create it. But house becomes its friend, therefore, as you see, again, I have series of pointers of rooms, but when a room is added, a room is not added. What you need to build a room is added to a house. It's house that builds the room, not you. You add a room, you tell to the house what is the room name. The house builds a room and puts that name on it. It's the house that builds the room and adds it to itself. And obviously, when the house is gone, it's the house that is deleting it. No one outside can create a room. No one outside can destroy a room. It's house's responsibility to create or destroy the room. That's composition. Okay? Are we good? All right. And that's your quiz next week. So I'll give you 2 classes. I'm going to say, I don't know, table and seats and chair. And I'm going to say, create an association for me. Then you have to do a proper thing between them. I'll tell you what the functionalities are. Then you create an association between them. And I'm going to tell you, anyway, I have to come up with it. I don't know if I don't want to use my my thoughts because it's very difficult to design a question. So I'll tell you what it is. So essentially, I'll give you 2 classes, and I'm going to tell you what the functionalities and an interaction between the classes are. And I'm going to tell you, create a composition. When I create a composition, you have to do it this way, which means you have to make the class private, you have to yada, yada, yada. When I make an association, you have to do it. So that's your quiz for the next day, for the next lab. We good down to this point? So again, long time ago, in a galaxy far, far away, I have created a library. So it was better times that the examples we wrote were more complicated than just the 2 classes that I have written. So essentially, this is somewhat a mixture of association and aggregation. So you gotta take a look at it and see how it works. first I show you what the thing is, and then I'm going to superficially tell you how they work. I want you to go home and walk through it. Okay? Walking through, try to learn how it works, how this code is written and how it works. Okay? And that's going to give you lots of insight. It's a good walkthrough to go through. And it's going to help you understand many things about C++. So, we didn't talk about pointer to pointers, did we, in this class? Pointer to pointers? No? Anyways, I'll go through it quickly so you'll see what it is. So, essentially, I have library class and I have book class. And each library is created like that. You see, Vaughan Library, Toronto Library, Yorkdale Library. And then I have C++, C reference, CPP, and series of books created. So I have books, I have libraries. Then I create an array of pointer to all these libraries. So address, so L0 becomes the first library, L1 to L2. I don't know why I have 4 when I have 3 over here, but anyways, we can make that 3. And then I have 7 books over here that I say, oh, it's a null terminated array. So I made it null terminated so I can find out I don't have to keep the size anywhere. So it's a null terminated array of libraries. You have a null terminated array of characters. That's a string, right? So I'm going to go until I hit the null. That's what I did. Anyways, same thing over here for books. So when I show the library, so let me show you what happens over here when it runs. Build errors. In what? I think it's building this. And I don't have anything in here, that's why. Remove. Okay. People on the last row, can you see this? Is it too small or you can see it? You good? Okay. Okay, so the library is created. All these things are created, and I have the pointers. So essentially, L0 is first one, L1 is second, L2 is that one, L3 is null. Therefore, I know where it ends. Same thing over here. Now I'm going to say show library. So it actually goes over here. It's a pointer to pointer, right? So it goes over here, and this shows the first library and goes to the next one, and next one, and next one. So it shows all the libraries one by one. Okay? Simple and straightforward. And as you see, that's that, right? Now I come over here. Now I'm using the exact same thing to show the books. So I'll go to the template. Now I have a pointer to pointer, and it shows the books one by one. Are we okay with this? Now I'm inserting the books into the libraries. So now my Vaughan library will have C, Crime and Punishment, and what is the other one? Fox and Socks. Toronto library, we're going to have C++, C, Green Eggs and Ham, and Harry Potter, and so on and so forth. So these, one by one, insert the books inside the library. And because of the association that I have, when I show the library, what happens, it not only shows the libraries, but also the books inside. So when I go, it still goes to the same thing. But in here, when I'm actually showing that, it shows Vaughan library, and these are the books available in them. And the next, and the next, and the next. Are we okay with this? Right? And now when I go back and I show the books, now each book that it shows which library the book is available in. Again, next one, next one, and next one, and next one. So one by one, we know exactly which books are in there. And we get up. So this is essentially, and now I remove a book from that, remove book from this, show everything over there. These are the libraries. These are the books. Everything gets updated and so on and so forth. Okay? Now, how it works. Why I want you to actually go home and walk through this. Because to be able to do all this, I had to write a manipulator. Do you remember what manipulators were when you were actually printing stuff? You had two ways to format your text. You could just say cout.width 10, semicolon, so the next printout had a width. Or you could say cout, insert, set W 10, insert, halfway through your code. Right? Those are manipulators. Manipulators are actually sitting between cascading commands, cascading statements, and change the content. What I want you to do is to go and take a look at this and try to understand how it works. So essentially, what I have is a class called IOable. So essentially, everything is in here. They can be displayed. They can be displayed. Something that is input outable, obviously, because it has able at the end, it means it's an interface. It must be able to display itself. It must be able to hide its own subcontent. And it should be able to be readable. So these are the things that an IOable can do. Okay? Then I create a library out of that. And library has all the stuff that it's supposed to have, as you see. Okay? And the same thing for a book. And as you see, they both have hide subcontent. And this is my manipulator. And as you see, the manipulator that I have has nothing to do with these classes. Essentially, what it does, it sits between two objects. I put it in IOable. This is the manipulator that I'm writing over here. It is supposed to be a singleton. I haven't made it a singleton. I'll teach you later on when the time comes what a singleton is. Singleton is a class that can be only instantiated once. You cannot have two instances out of it. Okay? Anyways. So essentially, it knows what is it printing on. By default, it's cout. It knows how to set the OS, and it knows how to sit between an IOable and itself. So essentially, it receives an IOable at right side of this one, returns an O stream back. Therefore, it can sit halfway through our execution. And obviously, it has insertion operator overloaded. Also, it's instantiated an extern make it global. So hide next subcontent is the name of the singleton that is made out of hide subcontent. What happens is that, and I want you to go actually walk through this one, is how a book or a library can show itself. Take a look at this. You see that? When a book is displaying itself, first it prints the title. It says, am I hiding the next print? If the next print is being hidden, this is going to happen. Otherwise, this is going to happen. But when the next one is not getting printed, it says, hide me, which means the causality loop is not going to happen. If I didn't have this if statement over here, when you print a library, this always happens in associations. If I print a library, it will print its book, right? And when you print its book, the book will print the library that it exists in. And the library that it exists in is going to print the book that it has. And the book that it's going to go forever. So this prevents it, okay? And I want you to walk through it and see how it works. I'm not going to go through it in detail. That's it's something good to just go through and see. The reason that I gave this as practice for you guys to actually go through and see how it's done is the fact that usually that's the first job you're going to get when you get hired as a programmer, fixing other people's code, okay? And this is what you need to do. You need to be able to have a piece of code and try to find heads and tails out of it, okay? And hopefully you're not going to curse me too much on this. Anyway, so that's that. I leave the code over there voluntarily. If you want to go through it, good for you. If not, throw it away and don't do anything about it. And that's essentially end of the relationship between objects. Now the only thing that remains is tell you what pointer to pointers are and be done. Okay? We talked about pointers and we know what they are, but what are pointer to pointers? Questions down to here. Is it because it's Friday? Everybody's like this? Believe me, I don't want to be here either. I want to be going home sitting, you know, I want to say sitting outside, but that you can't do now. It's not a good time. But anyways, don't worry, we're going to be done. I'm just going to talk at like 10, 15 minutes, and then we'll be gone. Any questions before I jump into pointer to pointers? Suggestions? Anybody wants a break, or you want me to be done with it? Break? Anyone? No? No, let me go. Okay. All right. No. Anyways, so pointer to pointer, let's see what they are. Oh, the file exists. I can just add it. Cancel. Add existing item. Okay. So I have integer a, and I have 5 things in it. And let's say, I want to say, let's say we are doing C, but no, let's do C++. We're good with that, right? We okay with that? All right. So if I say over here, integer pointer PTR set to a, are we all good with this? You're okay with this? Right? That's a pointer, right? So essentially now 2 things are pointing to that array. So if I go over here, actually let me do something else. I can go for integer I set to, because I have to keep printing. I'm going to do that. I'm going to say I less than size and I plus plus. I set to 0. Oh, actually, if I. Then I'm going to say cout. Cout ARI. So I can say over here print PTR, if I can type it, and 5, and hopefully it's going to print the 5 numbers. Oh, it's going to run the other program. No. So let's start a project. All right, we're good? All right. Now, my question is this. If I go PTR++, what is the output of line 17? 200, right? Easy, right? Fantastic. So I'm going to say integer. I'm going to say void advance integer pointer p. And in here, I'm going to say p++. Now I'm going to say advance. And I'm going to say over here PTR. And I'm going to say, let's not have extra spaces for no reason. What is the output of line 22? What is the output of line 22? Huh? 300? Still 200. It's not going to be 300. Don't give pointers extra credit. Pointers are just variables. And remember, in C language or C++, everything is passed by value. Nothing is passed by address. That expression that they have, this is passed by address, this is absolutely BS. Everything is passed by value. Sometimes that value happens to be an address. As that value could be a double, as that value could be a character. So in here, when I am advancing PTR, I am passing a value. The type of this is integer pointer. The type of this one is integer pointer. So PTR will be copied into the same variable, same type of variable called P. P becomes a copy of PTR. It will be advanced. Good for him. It will be gone. P dies. Nothing happens to PTR. How can I fix this to advance it? I can use an easy C++ way. What is a C++ way to fix this? Reference. My name is Fardat, call me Freddy, right? Give it a new name. So what I can do in here, I can just do this. And done. Problem solved. Now P, remember, there's something that I have to. Now I have something that I have to tell you. Why is it giving me an error? Oh, okay. So remember, whenever you are calling a function, the function is actually called like this. To understand how it works, you have to do this. This is literally how the function is called. Literally. You understand? Literally. When I didn't have that ampersand, what did it mean? It means integer p equals to PTR. Therefore, p is a copy of PTR. Therefore, anything I do with p, anything I do with p has nothing to do with PTR. Right? Right? Now, if I do this, P becomes a new name for PTR, and whatever I do to it, actually I'm doing it to PTR. Therefore, now if I run this, that happens. Correct? Are we okay with this? Now let's say we are not in C++, and this is a C program. We don't have references. How you want to accomplish that? So let's make it easy. If I have over here integer integer I set to 10, and I want to add 1 to I, what do? I'm going to say integer pointer PTR, right? Then I'm going to say target of PTR will be added by 1, right? Oh, pointer. Who said pointer? Pointer. Target of PTR is added by 1, right? And then when I want to actually add 1 to it, what do I write? I'm going to write add 1, and I'm going to put address of I here. Therefore, when the function is called, it is called as follows. Correct? Therefore, PTR holds the address of I. Whatever I do to the target of PTR, I am doing to I. Are we okay? That's IPC 144. We okay with that? So let's apply IPC 144 to 345 now. What I'm going to do in here is this. What I'm going to do here is this. I am going to say I want the advance to be like this. Address of PTR, like I did address of I, right? Correct? When I had an integer I, what did I have to do? I had to add an asterisk to it, right? So if I'm writing an advance in that way, I have to say integer, pointer, that's the type, correct? I want a pointer to it. The rest is the same, target of PTR plus plus. And now this will actually advance. Oh, if I put a semicolon, it will advance. Otherwise, it will give me an error. And now we have 400 over there. Again, don't give pointers extra credit. They're just types. So if I have an integer, to handle an integer, I create an integer pointer. If I have an integer pointer, to handle it, I need an integer pointer. Now, if I have an integer pointer, to handle it, I need an integer pointer. If I have an integer pointer, to handle it, I need an integer pointer. Doesn't make any difference. They're all types. Followed? That's all. It's, again, if you apply the same rule you've done to pointers, everything's the same. That's why teaching it is not very important. Just apply it. Just apply it to the fact that integer pointer is a type, and you can create a pointer of a type. Easy. We good? And that's why we needed integer pointer over there in the other one. Why did I need an integer pointer over there? The reason was, come. Where's it? The reason was that this is an array of pointers, right? And they are holding an address. So to get to that address, I have to go into library pointer. And that's why I had to get library pointer over there. That's the only reason. And to get to the target of it, the first one goes to the array. The second one goes to the object. I have two asterisks over here, target of. I have the first one goes to the array. The second one goes to the object. I have two addresses. So it's integer pointer. And that's that. Questions? Suggestions? Objections? Anyone? You good? You're okay? Ready to go? Nothing else? Okay. All right. How many this weekend? I'm going to start marking your 244 tests. So get ready for me to tell you how much you need to study. Number 2, it's been like 3 weeks past, and I didn't have a single appointment from anyone asking me I didn't understand the possibilities. Either I have taught it so well that everybody got it just like that, and everybody's master of their domain now, or none of you got anything and you don't care. So I think the second one is kind of, please book your appointment. I have lots of I have Tuesdays completely off. I have Thursdays completely off. Open to book appointment. Please, if you have any problem with any part of the things that you see, book an appointment and I'll take you through it and I'll help you. All right? Shall we? All right. Thank you and have yourself a beautiful day. And I will post this right now, unlike last time that I forgot to do. Give me a second. Give me a second. Let me put this thing. I just want to submit. Pardon me? You're still recording. Oh yeah. Oh. Sorry. So let me stop recording here. Stop recording here. Stop. And stop recording here.